I welcome everyone. I'm myself, Dr. Ravi Kumar. I am the host for the day and the conference session chair for the day. So it gives me immense pleasure to be part of this conference and to chair this session for the day. And let me just go ahead and brief up about the organization with a small brief up about the organization. So to brief about the firm, the let me just yeah. So to talk about the organization, right? The organization, Research World, World Research Society, right? We have yeah. So welcome to the industrial the members meeting organized by World Research Society, associated with IASTEM, Research World, and Techno Conferences and Academics Era. And the organization is a world largest non-profitable organization, which is basically meant for research development and promotion in the field of science, technology, and management, economics, social science, and medical health sciences. So the organization is being conducting conferences approximately more than a decade, and have conducted more than 800 plus physical conferences till date across the globe. Across the globe in various countries, and also to name, also to add on a few more points, the organization has around 10 international reputed journals, and also with respect to MOUs, we have signed, and we generally collaborated with elsewhere and other science index and other few journals, right? So this is a just brief about the organization and what the the legacy with the organization is all about. And just to name something about the facts and figures, more than 50,000 plus papers has been published in the organizations till now, till date. More than 50,000 papers has been published. More than 1 lakh people have been associated till date. So these are some of the numbers with respect to the associations, more like a further in it happen, right? So with this, we'll quickly go ahead and start up with the.
Good afternoon to everyone. This is Dr. Shimul Dai, Associate Professor from the Department of Environmental Science and Resource Management, Maulana Bashani Science and Technology University, Bangladesh. And today I'm going to present my research work on development of emission inventory for thermal power sector and future carbon emission reduction in Vietnam. So here are the authors, myself and Dr. Sachin. So this is the presentation rundown. On the first section, I will discuss about the introduction and objectives. Then I will start with the data and methodology. Then I will go for the results, that is the Vietnam point source emission inventory and emission projections, and potential emission reduction using renewable and sustainable energy alternatives. So let's start with the first section. So this study area is in Vietnam. So in Vietnam, the emission of pollutants from various anthropogenic sources are increasing day by day. So among the anthropogenic sectors, thermal power plants is considered one of the key contributors, as the energy demand is increasing in Vietnam. And to meet the growing electricity demands, government has to rely on especially the thermal power plants. So that's why the concern is that emission reduction and mitigation is important in the country. So different regulatory measures are taken and approved by the Vietnam government in order to reduce the future carbon emission in Vietnam, including improvement in existing power sectors by installing different devices for controlling sulfur dioxide or NOx, and using the renewable alternatives in the power sector. So these are the objectives of my research, to develop an updated emission inventory for the thermal power plant in Vietnam, and it's compared with the available global and regional inventories, and to estimate the net global warming potential of emission, to project the future carbon emission in the power sector, and how different regulatory measures affect the current and future emissions, and in terms of reducing carbon emission in the power sector. So the next section I will discuss about the data and methodology in my study that I've used. So these are the different data sources that have been used in this study, which is collected from different local sources, personal communication, international databases you see here, and different global and regional emission inventory databases. So here is the methodology for estimating the annual emission from the thermal power sector in Vietnam. Here I considered the activity data, that means the annual fuel consumption in the power sector, in the power plant, and the emission factor of different pollutants, and finally the emission reduction efficiencies of each of the individual power plants. And this method is used for estimating the global warming potential of emissions, considering the annual emission from each of the power plants, and by multiplying with the global warming potential of the pollutants. So here is the overall scenario for the methods used for emission reduction using renewable and sustainable alternatives. In our study, we considered only municipal solid waste and solar power as a potential renewable and sustainable alternatives to reduce future emission in the power sector by using different sorts of equations here. And we also did a scenario analysis considering different factors. And finally, we did a life cycle assessment for municipal solid waste to electricity production. Here is the system boundary for life cycle assessment. So turning to the next section, I would like to discuss about the results of our study. So in Vietnam, the thermal power plants are mainly clustered in the northern parts, mainly the coal-fired power plants. Here you see, and in the southern part, it's clustered with the gas-fired and oil-fired power plants. So here is the annual emission estimation for the thermal power plants, uh, like the coal-fired, gas-fired, and fuel-fired power plants for different base years in 2015 and 2010. So here you see the emission growth rate between 2010 and 15 ranged from around 12% to 170%. So here the ash color represents the power plants that are installed with different emission control technologies for sulfur dioxide emission control, NOx emission control, and particulate matter emission control. So here you see the emission growth rate for sulfur dioxide was negative, which was around 19% between this period, because in 2015, all of the thermal power plants, all of the coal-fired thermal power plants are equipped with uh, FGD system, that means the flue gas desulfurization systems to control the SO2 pollution emission. So this study also compared the results with available databases that published the global and regional emission inventories. So results show that our result is comparable with available emission inventories, with some exception. For sulfur dioxide, you see our estimation was much lower compared to the global and regional inventories, mainly because of the installment of emission control technologies. And in this study, we used a bottom-up emission inventory approach, whereas the global and regional inventories mainly use the top-down approach without considering the local activity data. So that's why this is the main reason for these differences. So we also estimated the global warming potential of emissions for different base years. So among the greenhouse gases, the emission was the highest from the carbon dioxide, and for the short-lived climate pollutants, the emission was the highest from the NOx. So this figure shows the emission from individual power plants in Vietnam in 2015. So you see, among the 36 power plants, the 21 was coal-fired power plants, and among the coal-fired power plants, the emission was the higher from Palai 1 power plant, because this power plant did not install any sulfur dioxide emission control systems before 2015. So this is the regional share of emission in 2015. You see, there among the 5 regions in Vietnam, emission contribution was the highest from the Red River Delta region, that is the uh, northern part of Vietnam, which was mainly because of the cluster of coal-fired power plants which was operated in this area, followed by North Central and Central Coastal regions. As in between 2010 and 2015, a couple of new coal-fired power plants was installed in this area. So this figure shows the uncertainty analysis, as emission inventory is always associated with uncertainties due to the choice of emission inventory approach, the estimation approach, the sources of local activity data, and so on. So in this figure, we can see that uncertainty was the highest from for NOx. It should be mentioned that this solid bar represents the best estimation, but the whisker represents the lowest and highest estimation. So this highest uncertainty is mainly due to the different sources of emission factors that have been collected from different global and regional emission inventory studies and databases. So this is the projected emission in 2015 based on the base year of 2019. So here you can see that emission starting from 2020 is increasing gradually, and however, the emission of NOx was almost in 2030 was almost similar to 2019, the base year. This was mainly because of the installment of selective catalytic reduction system for controlling the NOx in 2030. So I considered different scenarios like the business as usual and the emission control scenarios by considering different emission control system in the power plant sector. So this is the spatial distribution. Here I tried to show how different regulatory measures can affect the future emissions in terms of NOx. For example, here the 2019 was the base year emissions, and the 2020, 25, and 30 was the future emissions. In 2020, emission was almost similar to 19, as the number of power plants was almost similar. In 2000, however, in 2025, emission has changed drastically in the central part of Vietnam due to the installment of more coal-fired power plants. However, in 2030, emission has changed or reduced significantly due to the as the government has taken different emission control technologies and approved different projects to control the future emissions until 2030 based on the COP21 agreement, that is the Paris Agreement. So in this section, I will discuss about the potential emission reduction using solar power to electricity and municipal solid to electricity. In 2030, we can see that potential electricity generation could range from around 12,000 to more than 14,000, and potential emission reduction in the thermal power sector. I mean in the total emission of thermal power sector could range a maximum of 17,000 gigagrams CO2 equivalent. In terms of municipal solid waste, the potential electricity generation could range from more than 8,500 to around more than 18,000 gigawatt hour, and the total emission reduction could range from around 1,000 to around 10,000 gigagrams CO2 equivalent. So here is a comparison study with the for per kilowatt of electricity production regarding in terms of emission from the coal-fired power plant and the municipal solid waste to electricity strategy. So here you can see that existing thermal power plant can emit more than 0.9 kg CO2 equivalent per kilowatt of electricity generation, where the range of municipal solid waste to electricity production could range from zero point 0.4 to zero point 0.7 kg CO2 equivalent per kilowatt of electricity generation. So it could be a possible future strategy to reduce carbon emission in Vietnam. So in conclusion, I would like to say that in this study, we developed and updated a new emission inventory with emission projections for the thermal power sector. And here you can conclude that emission status will be the highest from the coal-fired power plants until 2030, as the operation of coal-fired power plants will not stop until 2030. And the emission growth rate ranges from more than 8% to 340%. And emission was the highest from the Red River Delta region, followed by North Central. And there is a potential reduction of NOx and sulfur emission in the coal-fired power plant due to the advanced technologies and the strategies that are taken by the government. This study also concluded that potential emission reduction is possible using solar and municipal solid waste by using renewable technologies. Therefore, we suggest that promotion of large-scale uses of renewable sources in the thermal power sector is possible for future decarbonization in Vietnam. So thank you all. This is the end of my today's.
Good evening, everyone. Myself is Suresh Laudari, PhD student of Ehime University, and I'm also the researcher in Kochi University Geotechnical Engineering Lab, Japan. So now, today I'm going to present about improved Cavian technology for riverbank protection and flood control about in Nepal and similar developing countries. Professor Dr. Tadashi Hara from Kochi University and Professor Dr. Hiroshi Nakazawa from Shizuoka Institute of Science and Technology, Japan are the contributors for this research. So this is the outline of my today's presentation. I think you will be clearly know about this. So now let me talk about Gavian. What is the Gavian? The Gavian is the wireless baskets or containers that fill with earth or stones used in building structures such as dams and dikes. So in this the figure you see, this is the typical Gavin box that are used in Japan, and there are different variety of Gavin boxes used in different parts of the world, different nations of the world. Typically, Gavins are used in the world from Egypt. It's around 7,000 years before. In while we talk about Japan, it's around 16th century. Gavin are in use for riverbank protection from traditional bamboo gavins called jajako. In Nepal, early 1970s, gavins are used for the roadside slope protection. So nowadays, gavins are used to secure shorelines, riverbanks, highways, and slopes against erosion in Nepal and worldwide. So far there is very limited studies have been done in Gavin technology in Nepal and worldwide also. So in this study, we'll do the on-site investigation of the Gavin technology in Nepal. So let me try to compare the prevailing Gavian construction and design practices in Nepal and Japan. So these are the parameters that I want to compare. In Japan, they apply the very good standard of planning and design process, while in Nepal, local practices are dominant. So in Japan, hydrological, seismic, environmental, and geotechnical parameters are considered while in Nepal, only hydrological parameters are considered. In Japan, there is detailed topographic survey and right of waterway channel have been considered during design and construction, while in Nepal, only general topographical survey is considered in design and construction process. So while in the construction process, there is very rigorous construction process have been done in the case of Japan with strict supervision from the Gavian experts, while in Nepal, and they follow only the local construction practices. While we talk about the construction material use, in Japan, high quality of construction materials used, good quality of wires with the zinc coat and with similar type of stones, size of stones are used, geotextiles are used, and there are varieties of the Gabion materials. Gabion boxes are available in the market for construction material. But in Nepal, very limited variety of Gabion wire mills are used, and mostly locally available materials are used, and these are mostly the low quality of the materials that are used for the construction and design of the Gabion. So while we talk about the durability, in Japan, gabions are highly durable and it's around 40 to 50 years durable. While we talk in Nepal gabions, it's around very few years they are damaged, and maximum 10 years durability found in about Nepal gabions. So, so while we talk about the Gavian cost, there is a high initial cost of Japan, but overall payback cost is comparing to the Nepal Gavians are low. We found this like that. So overall, while we talk about the maintenance, there is very clear maintenance plan in Japan, Gavian, and there is not any maintenance operation and maintenance plan in case of the Japan Gavians. So overall, Nepal prioritize the cost effectiveness and the local material for design, but while Japan emphasize the long term and resilient engineering design for the thing. So let me talk about the Gabion design construction methodology inside, which is done in Nepal. As I already told you, we did our inside investigation in the central part of Nepal in a small river. This is Kharkola River, where total of 965 people are affected and 250 households are affected from this river. So in this river, very few civil structures and embankments are provided, and the flow every year the flow overtop the bank of the river and flooded nearby the area and damages the infrastructures and agricultural land nearby. So we have also installed the rain gauge station at that area, and as per the data observed from 2022, it's around 2,000 millimeter of rain have been fall in that area. So from the hydrological analysis, we found that the high flood level for the river is 3 meter for the 100 years of return period, and to 2 meter for 30 years of return period. Why we consider the river route with 18 meter. From our in our research, what we really focus on the problem is problems in the gabions in Nepal. The problem is very less durable and damage is fast and very unstable, and there is no stringent standard of design and construction practices happening in Nepal. And that is the main problem in Nepal that we see, and we want to focus and investigate on that. On that thing. So while we talk about the Kharkola River is with very few embankments, and there is every year bank erosion and overflow. Here you see in the figure there are some gabion embankments are provided, and you see there is the tilting of the gabion and from the top of the part, and there is also the damages of foundation of the gabion, and there is the wash away of the stone from the foundation, and also the foundation failure happened in the provided repeatment gabion structures in the river. So to investigate in the river, so we did some soil geotechnical analysis in the river. So to do the geotechnical analysis, we collected the sample from the river and did the seams analysis. From the seam analysis, we found that the topsoil is consisted with 9.4% of the fine particle, while middle and bottom soil is only 1% of fine particle we found. As for the grain size analysis, the foundation soil is about around 80% of gravel. So why we did it, this is the what the soil structure we found it from the sieve analysis. So then after the sieve analysis, we did the portable dynamic cone penetration test in the site. So from the PDCB test, we found that the top layer is soft soil, and the middle and hard layer is middle and bottom layer is we found the hard soil. So from this geotechnical analysis, we found that the foundation and the middle part of the soil is hard soil. So there is no need of the no need any foundation treatment for providing any type of structure in that soil. So that is really. So I so how we did PDCP. This is PDCP method. We what we provided to do to find out the soil density, load bearing capacity, and shale strength. This is just I show you how what is the PDCP and how we did PDCP test in the field. So after doing the this soil geotechnical analysis, we developed the new design concept, Gavin concept for that is suitable for Nepal. And so how we did is first we select site, then we finalize the design from series of discussion with experts from different sector involving the local people. Then we developed two type of design for that site. One is Japanese type design, and another one is Japanese and Nepali mixed type design. How we can develop this is we involve some good and standard parameters from and practices from Japan, and involving some local practices of Nepal. So these are the two design we developed and investigated this design in the site. So why we choose Japanese design for Nepal is because Japanese have their very long term and resilient and stringent design and standard construction process. They are very good quality of construction materials that they are using. They follow the technical standard that is accredited by government of Japan. They consider the seismic, geotechnical, environmental, hydrological situation of the site. These gabions are highly durable. They have good maintenance plan, and even though the initial cost of investment is high, but overall payback is low. So that is why we follow the Japanese gabion system, Japanese gabion practices in our technology. So this is the construction process that we follow in our site investigation site. Uh, so after the investigation, then I will talk about our results and discussion. So what we found is about about the adaptation of the Gavin technology, Japanese Gavin technology is that what we adopt is what we follow the rigorous engineering standard, that is we do detailed topography survey, soil geotechnical analysis, hydrological analysis, series of discussion for finalization of design to adapt in the local level. So we follow the construction materials that are available in locally available materials. We follow the rigorous construction process like regular supervision, proper sizing placement, and use of machine, something like that, and then we use some maintenance plan. So what? So then, what we found between these two type of the design is that we follow the new standard design for both of the design. Then we use the locally available materials for both of design, but only for Japanese type we follow the WRS that are fit for the Japanese system. That is with 50 centimeter height and with lapping 25 centimeter. But in case of Nepalese and Japanese mixed type, we apply the height of 100 centimeter and with a lap of 50 centimeter. We use geotextile for both type of design. So while construction is while talking about the construction easiness. For Japanese type, there is somehow the needed the construction training for the workers, but this mixed type, because of the 100 centimeter height, these are mostly used constructed in Nepal system. That is why very few training can trained worker can construct this type of design. So while we talk about the cost of construction, Japanese type of design is more costlier than this mixed type of design. And both of the system we apply this maintenance plan by the community. So after construction, we did some horizontal and vertical deformation of two these two type of the design that we installed in the site. So from the every month after March. So from the data, we found that there is very little deformation found in mixed type of design. This only 3 centimeter, and this is very negligible compared to the other system. So in conclusion, that is what we found in the system. So now I would like to conclude my presentation with my of the research findings here. So overall, Gabion technology is a cost-effective and environment-friendly solution for flood control and erosion control, and widely used in many parts of Nepal and other developing countries. The improved Gabion technology seem to be the most effective, durable, and adaptable for Nepal and similar countries. So we will further analyze the best possible Gabion options and construction technology option which is suitable for Nepal and similar context. So we are doing some regular monitoring, monthly monitoring in the site and also in the lab for the both type of design. And after the result from lab and the in the site, they will we can analyze and recommend the best possible option for the payment system. Thank you everyone for listening me.
Everyone for your kind patience and kind connection. It's nice connecting with you all. Thank you. So I don't see